Boy, I'm talkative today. So hi, welcome back. This is Liouville's theorem part 2. Every bounded entire function has to be constant. The way I'm going to prove that is I'm going to prove that the modulus of the derivative at every single point has to be 0. And so I do that by using Cauchy's integral formula, or at least a modified version, to say that the derivative is equal to this integral. And I can prove that this integral is less than or equal to m, a constant that bounds f, divided by r, where r is the radius of the circle that you're integrating over. But the key point is f is entire. So no matter how big you make the circle, this integral is still going to make sense. And it's still going to be equal to this value. So I have f prime of w, the modulus, is less than or equal to m over r for every single r. Well, as r goes to infinity, well, I suppose one way of saying that is that if it's true for every single r, the only possibility is that it has to be equal to 0. If you say that's 0.1, I can pick r big enough so that this thing is less than or equal to 0.1, and I'll show you, no, it couldn't have been 0.1. If you think that this modulus is 0.000001, I'll just pick r big enough so that it's smaller than whatever number you just chose. So the only possible number is that it has to be 0, which implies that f prime of w has to equal 0, which implies f is constant since f prime of w equals 0 for all w belong to r. Because right here I'm going to prove it for all, so I could have picked any point here. So no matter what the point is, f prime of w is going to equal 0, and we're done. That proves that's constant.